Hello everybody, welcome to Guidancee Education channel. We will see the topic that is discussed in this video. We are continuing class 11 physics, thermodynamics, and that we will be doing PV diagram. Part 1. In this part, we will be discussing PV diagram for isothermal process. Significance of PV diagram. This topic is very important, so watch the video without skipping. And if you think the video is useful, do like the video, share the video, and also leave your feedbacks as comments in the comment box below. If you have not yet subscribed my channel, do subscribe it now and support me. And also press the bell button and all button for notification of new videos like this. Thank you very much. Come, let us start the topic. We will discuss PV diagram for thermodynamic processes. This is also known as PV graph or indicator diagram. The shape of the graph depends upon the type of the thermodynamic processes like isothermal, adiabatic, isobaric, isochoric, cyclic, etc. We will discuss the shape of this PV graph for these different processes one by one. Also see the significance of PV graph, that is the importance of plotting this graph. By the by, what is PV graph? It is a graphical representation of variation or change of volume with pressure. We will first take up isothermal process. As you already know, isothermal process is one where temperature is constant. The y-axis and x-axis are marked, the origin is marked, pressure is taken along the y-axis and variation of volume is taken along the positive x-axis from the left to right. When variation of volume against pressure is plotted, for isothermal process, it has the shape of a slope. This is the initial volume V1 and this is the final volume V2. We have done the PV diagram for isothermal process. PV is equal to nRT. So for isothermal process, PV is a constant, which means P is inversely proportional to V. That is Boyle's law. So in this graph, the slope represents the increase in volume for the decrease in pressure. Volume increases in the positive direction. This is expansion work. That is, the system is doing work on the surrounding. What is the significance of PV diagram or PV graph? We have already derived an equation for calculating work done during thermodynamic process by the process of integrating all the delta work done during small expansions or compressions. Anyway, total work done can be calculated using this PV diagram. That is easier than using the formula. So the significance of PV graph is that it helps to calculate work total. We have to see how this is done. For that purpose, the distance V1 to V2 is split into several infinitesimally small segments, that is dV, and the work done for these different dV is determined in a different way. Let us consider one or two such dV. Let us mark this segment as dV1. For this small difference in volume, it has one initial value and one final value. What will be the pressure reading? The pressure can be considered as approximately the same. We will mark it as P1. So this line represents P1 and this distance is dV1. This segment has the shape of a narrow rectangle with sides P1 and dV1. We already know that work done is equal to P delta V. For this small delta V, we can write dW1 is equal to P1 delta V1. And from the diagram, you can understand it is nothing but the area of that narrow rectangle. Now let us consider one more such region, delta V. Let us mark it as dV2. This is the initial and final volume for this dV2. The pressure will be approximately the same. We can mark this as P2. So this distance is P2. This gives another rectangle with sides P2 and dV2 and is smaller than the first rectangle. Work done for the expansion dV2 can be written as dW2 is equal to P2 delta V2. From the diagram, we can understand that it will be equal to the area of that rectangle. I will make a note of that here. In a similar way, the space under this graph can be split into several such infinitesimally narrow rectangular segments, and their areas may be calculated by simply multiplying their sides, that is the distance corresponding to pressure and the small distance dV. Each such area gives the work done for that particular expansion. So the work done for any arbitrary segment can be calculated from the graph without doing an experiment. That is one significance of this graph. When the areas of all these separate and several segments are added up, it gives the total work done. That is the second significance. There is no need to use the formula or integration. If we need only the total work done for the whole process, we need only to find the total area under the graph. In this graph, when pressure decreases, volume increases in the positive x direction. This is expansion work. V2 is greater than V1. Therefore, delta V is positive. So this is expansion work. But here you find that the shape is not regular. Anyway, the area should be split into several regular shapes like rectangles, squares, triangles, etc. And then the area of those pieces can be calculated and then added. I have noted a point there. Work total is equal to area under the graph. This is true for any type of thermodynamic process. Now we will take a PV graph for compression work. The shape of the graph is a slope. The direction of change of volume is opposite to the direction of change of volume in the case of expansion work. Please note the direction of the arrow. That is, volume decreases. Initial volume is maximum. Pressure is minimum. And the final volume is minimum. But pressure is maximum. Volume changes along the negative x-axis from right to left. So delta V is negative. Therefore, work done is negative. But area of the space under the graph is calculated in the same way. Applying the thermodynamic equation, delta Q is equal to delta U plus delta W. For isothermal process, temperature is constant. Therefore, there is no change in delta U. That is, delta U is 0. Therefore, delta Q is equal to delta W. That is, for isothermal process, work done is equal to delta Q. So, you have to remember these relations. We will discuss PV diagram for other types of thermodynamic processes in the next video. Otherwise, this video will be very long. If the video was useful, do like the video, share the video with your friends who may be benefited, and also subscribe my channel if you have not already subscribed. Press the bell button and all button for notification of more videos like this. Thank you very much for your support. Bye for the present. Take care.